these are the answers for the physics homework on home insulation. So the question says, the table below shows the amount of heat energy lost through different parts of a house. It also shows information about the types of insulation that could be used. So it's showing you the insulation on 3 parts of the house: cavity wall insulation, windows and loft, and it's comparing having no insulation in the walls or filling the walls with foam, having single glazing or double glazing, or having fiberglass insulation installed in your loft. So we've got 2 bits of information in the question. We've got the cost of the insulation to install and then the energy lost per second from a house at a temperature of 20 degrees C, and that's in joules per second. So joules is a way of measuring our energy and per second is per second. So part A says, explain how double glazed windows reduce heat loss from a house and use data to explain whether you would advise a homeowner to install this type of insulation first. So I've typed up the answers for you so I don't have to handwrite them. The first thing that you would want to say is you would want to talk about double glazing and how it actually reduces heat loss, and that is by reducing conduction and convection. So that's probably your first mark, is for mentioning that you know that double glazed windows reduce heat loss by conduction and convection. Then you need to explain how. So conduction is the kind of heat transfer that happens in solids, or with our solid particles, and it is reduced by a double glazed window because the air in the middle of our 2 panes of glass, so double glazed window, I'll just do a drawing for you on the screen now. You've got 2 panes of glass, and in between you've got air particles which are really spread out, and if you remember, conduction is from particles bumping into each other and passing on their heat energy. The particles are not close together, so that's not going to happen. So conduction is reduced because the air in the middle is trapped. Those are our particles, and air is an insulator. It does not conduct heat well. And our third point on here actually, convection currents. So that is how our gas particles change density. If they get hot, they spread out and they rise to the top, and if they get cold, they come together and they sink to the bottom. That current of air moving around transfers heat. But convection currents are reduced in double glazed windows because the gap between the panes of glass is actually quite small. So this drawing that I've done is obviously blown up, but if you were to have a look at double glazed windows, that gap is very, very tiny. So it's really hard for convection currents to be produced. So that's the first sort of 3 marks of this question, is talking about conduction and convection and how double glazing stops that kind of heat transfer. The second part of this question would be talking about the advice you want to give the homeowner. So the advice you'd want to give the homeowner is probably not to install double glazing first, and that's because if we look at the information in the question, if I have a look up here, I'll circle what I'm looking at. So the amount of heat loss per second, the difference between those numbers is only about 100 or something. That's quite a small number compared to these two. If I have a look, they've got a difference of about 400 and these have got a difference of about 600. So there's going to be more energy saved if you put cavity wall insulation or if you were to install fiberglass in your loft. But also you could have a look at the cost. So single glazing and double glazing, they're both quite expensive. So if you were giving advice to someone fitting insulation in their home, you might not want to do double glazing first because it is a high cost for not a lot saved, whereas cavity wall insulation and loft insulation are both cheaper and they save more joules per second at 20 degrees C. So your second lot of 3 marks here are for the advice you'd give the homeowner, and that's looking at the cost and looking at the amount saved. So you could do some maths if you wanted to back that up. So if you were going to do some maths, you would talk about the difference between these two. So you do 470 take away 210. For these ones you do 460 take away 310. And for this one, you do 380 take away 250, and that would just show the amount you saved from installing this. And you'd find the one from the double glazed windows is the least, it's the smallest amount of energy saved, whereas the others save a lot more, but it's the most expensive. So that is how you get your 6 marks. 6 mark questions are quite flexible, so you just need to show what you know and have a look at the data and what you can work out. So the second part B of this question, is a bit of maths. So John has bought a house which does not have any loft insulation or cavity wall filling. It only has old single glazed windows. He has decided to install fiberglass in the loft and fill the cavity walls with foam insulation. Use the data in the table to answer the following questions. So calculate the heat energy saved per second because of these changes. So what I've done, I've just pulled the table from the previous page onto this so you can see where we've got these numbers. So the first thing you'd want to do for this one, You're calculating the heat energy saved because he has put in fiberglass and foam insulation. So the maths that I was talking about with the previous question, this is where you'd want to do it. So let's first do his fiberglass in the loft. If we have a look, it is going to save us the difference. So this is the amount of energy lost per second before, 830, and then this is the amount after. So if we do 830 take away 250, that is 580. That would be joules per second saved by installing that. So that would be your first mark there. Your second mark would be for looking at the foam insulation. So this time we're looking at these two numbers. So we're doing 670 take away 210, which gives us 460 joules per second. So that's how much you would save by that. And then finally, it's asking you in total how much is saved. So we're just going to add those together. So you do get a calculator for your exam. And that would give us 1,040 joules per second. So that's how much we've saved from installing cavity wall insulation and from fiberglass in the loft. Part II, use the answer above to state the power to the home in watts. So joules per second is exactly the same as watts. So you're just going to put your answer from the one above. So if you put a different answer for the one above, you would still get 1 mark carried forward for that. Next part, calculate the total cost of installing both types of insulation. So this is just adding up the cost of both of them. So you're going to take the cost of the cavity wall and the cost of the loft. Add them together using a calculator, you will get £2,100. And finally, we've got payback time. So what that is the cost of installation divided by the amount that you save each year. So you're going to put on the top of it, you're going to put the cost. So let's put savings underneath. There we are. That's what we're going to do. Savings per year. So the cost we're just going to take from our previous question. It was £2,100 to install both of those. And the savings per year is going to be £150. So that £150 just came from the question, so that's our savings per year, £150. So we do the cost of installation, £2,100, divided by £150, that's 14 years. And what that means is that in 14 years, you would have saved enough money from installing the insulation that you've paid back the installation fee of £2,100. So that is the end of the exam question. Please self-mark your own work or write in the answers and let me know if you have any problems.